Imagine if just 10 minutes a day could reshape the very structure of your brain, sharpen your focus, and make remembering effortless instead of frustrating. Most of us accept forgetfulness as inevitable, blaming age, stress, or busyness. But what if memory isn't something that slips away, but something that responds, immediately and biologically, to your choices? Inside your head, billions of neurons are waiting for signals to strengthen, to connect, to create clarity. And the surprising truth is that you don't need hours of effort or complicated techniques to activate this potential. Just intentional, mindful practice can awaken your memory like a muscle long forgotten, ready to perform at its fullest. Memory is often misunderstood as a storage box, something that fills up, wears out, or slowly empties with time. This idea makes forgetting feel like failure and remembering feel like luck. But biology tells a very different story. Memory is not a thing you possess, it is a process your body performs. It lives in moving electrical patterns, chemical signals, and constantly changing connections between neurons. Every experience subtly reshapes the brain, and every thought either reinforces or softens these pathways. In this way, memory behaves less like an object and more like a living conversation inside you. When you remember something, your brain is not pulling a file from a shelf. It is reactivating a network that was shaped by attention, emotion, and repetition. This network survives only if it is used. If it is ignored, the brain does not punish you, it simply reallocates resources. From a biological perspective, this is efficiency, not decline. The brain is always asking one question: what matters now? Memory strengthens when you answer that question with consistent signals of importance. Gentle use is critical here. The brain responds poorly to force and beautifully to invitation. When you approach memory with fear or pressure, stress hormones interfere with neural communication. Cortisol narrows focus and disrupts the hippocampus, the very structure needed to form memories. But when you engage memory calmly, with curiosity rather than urgency, the nervous system remains open. Blood flow increases, oxygen delivery improves, and neurons synchronize more easily. The brain learns best when it feels safe. This is why small, intentional practices are so effective. A brief moment of recall, done with attention, tells the brain that this information has value. It might be remembering a conversation, visualizing a place, or mentally retracing a sequence. These acts awaken neural circuits and invite them to strengthen. Over time, synapses involved in these patterns grow more efficient, transmitting signals with less effort. Memory improves not because you demanded it, but because you participated in it. There is also a deeply human aspect to this process. Memory is tied to identity. The brain prioritizes information that connects to meaning, emotion, and purpose. When learning feels personal, the brain invests more energy. This is why emotionally neutral facts fade while moments of connection endure. By engaging memory gently and intentionally, you align with this natural preference. You are not trying to outsmart your brain, you are working with its instincts. Neuroscience shows that the brain remains plastic throughout life. Even in older age, neurons can form new connections. The myth that memory decline is inevitable is rooted more in habit than in biology. Many people stop asking their brains to remember deeply. Passive consumption replaces active engagement. When this happens, the brain adapts accordingly. It does not lose ability, it changes priorities. The moment you reintroduce intentional use, the system responds. This responsiveness is one of the brain's most hopeful qualities. Memory does not require perfection or long sessions of training. It responds to rhythm. Short, repeated engagement creates stability. The brain recognizes patterns of use and invests in them. This is why a few minutes each day can be more powerful than a single intense effort once a week. Consistency communicates trust. Another subtle factor is self-compassion. When people believe their memory is bad, they unknowingly reinforce avoidance. The brain associates recall with discomfort and resistance. Gentle practice reframes this relationship. Each successful moment of recall, no matter how small, rewrites expectation. The brain learns that remembering is possible, manageable, even pleasant. Confidence becomes biological. At a cellular level, memory formation involves protein synthesis and structural change. Neurons physically alter themselves in response to use. This takes energy, and the brain allocates energy where it sees return. Gentle, regular memory use demonstrates return. It signals that these circuits are worth maintaining. Over time, this leads to resilience. Forgetting becomes less frequent, retrieval becomes smoother, and mental clarity increases. Importantly, memory is not isolated from the rest of the body. Sleep, hydration, movement, and emotional regulation all influence how memory functions. Gentle memory practice often improves awareness of these factors. People begin to notice that memory feels clearer after rest, calmer after movement, sharper when stress is lower. Memory becomes a feedback system, guiding healthier behavior. There is also humility in understanding memory as a living system. It reminds us that forgetting is not a moral failure. It is often a sign of overload, fatigue, or unmet biological needs. When approached with respect, memory offers information about balance. It reflects how we live, not just how we think. In this way, strengthening memory becomes an act of care rather than correction. You are not fixing something broken. You are nurturing something alive. Each gentle engagement is like watering a plant, not forcing it to grow faster. The change may be quiet, but it is real. As the brain responds, something else shifts as well. Attention deepens. Presence improves. You begin to notice more because the brain expects use. Memory and awareness grow together, reinforcing one another. This creates a subtle confidence, not loud or dramatic, but steady. When memory is understood as a living biological system, the fear surrounding it softens. You realize that your brain is not working against you. It is waiting for signals. And when those signals arrive consistently and kindly, the response is not resistance, but cooperation. Short daily mental challenges have a unique effect on the brain because they align with how neural systems are designed to adapt. The brain is not built for prolonged strain without rest. It thrives on brief periods of focused effort followed by recovery. When you engage in a small cognitive challenge, recalling details, solving a simple pattern, or holding information in mind, you activate a cascade of physiological responses that begin almost immediately. Blood vessels dilate, oxygen delivery increases, and glucose is directed toward active regions, particularly the hippocampus and surrounding memory networks. The hippocampus is especially sensitive to stimulation. It functions as a gateway, integrating new information with existing knowledge. Research shows that even short bursts of mental activity can temporarily increase blood flow in this area, enhancing its ability to encode and retrieve information. This surge does not require intensity, it requires clarity of focus. The brain responds more to precision than to duration. A few minutes of intentional thinking can be more biologically meaningful than hours of distracted effort. Blood flow is not merely a transport system, it is a messenger. Increased circulation delivers nutrients and growth factors that support neural health. One of these, brain-derived neurotrophic factor, plays a critical role in strengthening synapses and promoting neuroplasticity. Short, consistent mental challenges encourage the release of such factors without triggering the stress response that long or forced tasks can cause. In this balance, the brain receives stimulation without threat, which is ideal for learning. Consistency matters because the brain learns through patterns. When a mental challenge appears daily, the nervous system anticipates it. Anticipation itself enhances readiness. Neurons involved in memory become more excitable, meaning they fire more easily. Over time, this lowers the threshold for recall. Memory becomes faster and more reliable, not because the brain is being pushed harder, but because it is being prepared regularly. Here is also a metabolic advantage to short challenges. The brain consumes a significant amount of energy, and prolonged cognitive strain can deplete resources, leading to mental fatigue. Short challenges respect these limits. They stimulate without exhausting. This creates a positive feedback loop. The brain associates thinking with vitality rather than depletion. As a result, motivation to engage increases naturally. Mental challenges also sharpen attention, which is inseparable from memory. You cannot remember what you never fully noticed. Short, focused tasks train the brain to sustain attention briefly but fully. This strengthens networks in the prefrontal cortex that regulate focus and working memory. Improved attention enhances encoding, making memories more durable. The effect accumulates quietly, day after day. Another important factor is novelty. The brain responds strongly to new or slightly varied challenges. Short exercises allow for frequent novelty without overwhelm. Changing the type of recall, pattern, or mental task keeps the hippocampus engaged. Novelty increases dopamine release, which further enhances learning and memory consolidation. This chemical support makes memory formation feel rewarding rather than effortful. Short daily challenges also interact with emotional regulation. When tasks are manageable, they reduce anxiety associated with cognitive performance. Lower anxiety improves memory function by reducing interference from stress hormones. The brain performs best when emotional load is light. Brief challenges maintain this balance, allowing learning to occur in a calm internal environment. Over time, these practices influence structural connectivity. Repeated activation strengthens white matter pathways, improving communication between brain regions. This enhances not only memory but cognitive flexibility. The brain becomes better at switching between tasks, integrating information, and adapting to new demands. These changes are subtle but cumulative, shaping mental resilience. The timing of these challenges also matters. Engaging the brain during natural energy peaks, often in the morning or after light movement, maximizes blood flow response. The brain is more receptive when circulation is already elevated. Short challenges fit easily into these windows, making them sustainable. Importantly, the benefits extend beyond memory. Improved blood flow supports overall brain health, reducing risk factors associated with cognitive decline. The brain becomes more efficient at regulating itself, balancing stimulation and rest. This efficiency translates into clarity, mental stamina, and emotional stability. Short daily mental challenges do not attempt to dominate the brain, they collaborate with it. They respect biological rhythms and energy constraints. In doing so, they unlock the brain's natural capacity for growth. Memory improves not through struggle, but through alignment. As this practice becomes routine, the brain begins to expect engagement. Neural networks remain more active even at rest. This baseline readiness enhances spontaneous recall and learning. Memory feels less like a task and more like a natural function, responsive and available, grounded in the simple power of consistent, focused attention. The human brain did not evolve in isolation from the body. Long before abstract thought or written language, cognition was inseparable from movement. Every decision, every memory, every act of learning was shaped while walking, reaching, balancing, and responding to the physical world. This evolutionary truth is still written into our nervous system. When thought and movement occur together, the brain recognizes a familiar pattern and responds with heightened coordination and efficiency. The center of this process is communication between the left and right hemispheres of the brain. These two halves are not separate thinkers, they are complementary systems connected by a dense network of nerve fibers. When movement is coordinated across the body, especially when it crosses the midline, signals travel back and forth between hemispheres more actively. This exchange strengthens integration, allowing analytical processes, emotional awareness, and spatial understanding to cooperate rather than compete. Simple movements paired with mental focus can activate this system powerfully. When you perform a gentle physical action while holding a thought, recalling information, or solving a problem, multiple brain regions engage simultaneously. Motor cortex, sensory cortex, prefrontal areas, and memory centers begin to synchronize. This synchronization improves timing and signal clarity. The brain functions less like isolated departments and more like a unified network. This unity has a direct impact on memory. Information encoded while the brain is integrated is more stable and accessible. Movement increases blood flow and oxygen delivery, while cognitive engagement directs that flow to relevant regions. The result is a biological environment optimized for learning. Memory formed in this state is not only stronger but more flexible, able to be recalled in varied contexts. Coordination also influences emotional regulation. Balanced communication between hemispheres supports emotional processing and cognitive control. When one side dominates, stress and reactivity increase. When both sides cooperate, the nervous system settles into equilibrium. This balance reduces internal noise, allowing memory signals to stand out more clearly. Recall becomes smoother, less disrupted by tension or distraction. There is also an attentional component. Movement anchors the mind in the present moment. The brain evolved to pay attention during motion because awareness was essential for survival. When the body moves intentionally, attention sharpens automatically. This heightened awareness enhances encoding. The brain remembers more because it is fully engaged. Even subtle movements can have this effect. You do not need intensity or complexity. Gentle bilateral motions, posture shifts, or coordinated hand movements are enough to stimulate cross-hemispheric communication. The key is intention. When movement is paired with awareness, the brain treats it as meaningful. Meaning amplifies memory. Neuroscience shows that motor activity influences cognitive flexibility. As movement patterns become smoother, neural pathways involved in planning and adaptation strengthen. This supports problem-solving and creative thinking. Memory benefits because information is integrated into a broader cognitive landscape rather than stored in isolation. It becomes part of how you think, not just something you remember. Movement also supports rhythm, and rhythm is fundamental to brain function. Neural oscillations coordinate activity across regions. Physical movement introduces external rhythm that the brain can synchronize with. This synchronization enhances timing, which is critical for memory formation and retrieval. Well-timed neural firing strengthens synaptic connections, making recall more reliable. The emotional impact of movement should not be overlooked. Physical activity, even gentle, increases the release of neurotransmitters associated with well-being. These chemicals create a supportive emotional context for learning. When the brain associates memory work with positive physical sensations, motivation increases naturally. Memory practice becomes something the nervous system welcomes rather than resists. Importantly, this integration fosters mental balance. Many cognitive challenges emphasize one type of thinking, often verbal or analytical. Movement engages spatial and sensory systems, balancing cognitive load. This balance reduces fatigue and supports sustained engagement. Memory improves because the brain is not overburdened in one area. Over time, repeated coordination between movement and thought reshapes neural architecture. Pathways become more efficient. Communication speed increases. The brain becomes better at integrating information from different sources. This integration supports not only memory but adaptability, resilience, and overall cognitive health. There is a quiet intelligence in this design. The brain remembers best when it feels whole. When thought is grounded in the body, cognition stabilizes. Memory becomes less fragmented, more coherent. The mind no longer feels disconnected from physical experience. This is not about exercising harder. It is about reconnecting. Small, intentional movements remind the brain of its origins. They restore a natural dialogue between thinking and doing. In that dialogue, memory finds its rhythm, clarity, and strength, responding not to force, but to harmony. Stress is often treated as an emotional issue, but at its core it is a biological state that reshapes how the brain functions. When the mind perceives pressure, uncertainty, or threat, the body responds instantly. Hormones surge, muscles tighten, breathing becomes shallow, and attention narrows. This response is useful for short-term survival, but when it becomes chronic, it quietly alters memory. The brain begins to prioritize immediate protection over learning, reflection, and recall. At the center of this shift are stress hormones, particularly cortisol. In small amounts and short durations, cortisol can sharpen focus. But when levels remain elevated, it disrupts the hippocampus, the brain's primary memory center. Neurons in this region become less flexible. New connections form more slowly, and existing ones weaken. Memory does not disappear suddenly, it fades gradually, as if the signal is being drowned out by noise. What is often overlooked is that the brain cannot distinguish between external danger and internal pressure. Worry, rumination, and constant mental urgency activate the same biological pathways as physical threat. The body stays in a state of readiness, and memory becomes collateral damage. Forgetfulness under stress is not a flaw of character or intelligence, it is a predictable physiological outcome. Calm awareness interrupts this cycle at its root. When you intentionally slow your breathing, observe sensations, or notice thoughts without reacting to them, the nervous system shifts gears. The body moves from a state of defense to a state of restoration. Heart rate stabilizes, muscles release, and cortisol levels begin to fall. This shift sends a clear signal to the brain: it is safe to learn again. As stress hormones decline, blood flow patterns change. Circulation increases to areas involved in memory, reflection, and emotional integration. The hippocampus becomes more receptive. Neurons regain flexibility. The brain is no longer bracing for impact, it is available. In this state, memory formation and retrieval improve naturally, without effort or force. Calm awareness also restores balance between brain regions. Under stress, the emotional centers dominate, while higher-order thinking becomes suppressed. When calm returns, communication between these regions improves. Emotional responses soften, and cognitive clarity increases. Memory benefits because information is processed with context and meaning rather than urgency. There is a misconception that calm awareness requires emptying the mind. In reality, it is about allowing the mind to be as it is without resistance. This non-judgmental observation reduces internal conflict. The brain no longer wastes energy fighting itself. That energy becomes available for repair and integration, both essential for memory health. Over time, repeated moments of calm awareness create lasting changes. The brain learns that not every thought requires action, not every sensation signals danger. This learning reduces baseline stress. Cortisol levels stabilize. Memory centers operate in a more favorable biochemical environment. Forgetfulness linked to anxiety begins to ease. Sleep quality often improves as well. Stress is one of the greatest disruptors of restorative sleep, and sleep is essential for memory consolidation. When calm awareness becomes a regular practice, the nervous system unwinds more easily at night. Memories formed during the day are processed and stored more effectively. The next day, recall feels clearer and more accessible. Calm awareness also influences how memories are retrieved. Under stress, recall becomes rigid and incomplete. The brain fixates on fragments. In a calm state, recall becomes more holistic. Associations emerge more freely. Creativity and insight increase. Memory feels less like searching and more like recognition. There is a compassionate aspect to this process. Calm awareness encourages a gentler relationship with the mind. Instead of criticizing forgetfulness, you observe it. This observation itself reduces stress. The brain responds positively to this shift. It functions better when it is not under constant evaluation or pressure. From a biological perspective, calm is not passive. It is an active state of regulation. It allows the brain to allocate resources efficiently, repair microdamage, and strengthen connections. Memory thrives in this environment because it depends on stability and balance. When calm awareness becomes part of daily life, memory improvement is no longer a separate goal. It becomes a side effect of a healthier nervous system. The brain remembers more because it is no longer overwhelmed. It has space to encode, store, and retrieve information with clarity. In this way, calm awareness is not a mental trick but a biological necessity. It protects the structures that allow you to learn from your experiences and carry them forward. Memory does not demand silence or perfection, it asks for safety. And when the brain feels safe, it quietly begins to heal, reorganize, and remember. Consistency is often overlooked in discussions about memory, but it is the single most powerful force in shaping the brain's ability to remember. Memory is not a static trait or a fixed resource, it is a dynamic, living process that responds to patterns over time. Every day, the brain makes decisions about which connections to strengthen and which to let fade. Consistent practice signals that certain circuits are valuable, worth maintaining, and worthy of energy investment. Without repetition, even the most extraordinary insights may dissolve into forgetting, not because the brain is failing, but because it prioritizes efficiency. The brain's energy is limited, and it must choose where to allocate it. Repetition communicates importance and ensures that neural pathways remain robust and accessible. The brain's approach to repetition is both subtle and profound. When you engage in a task repeatedly, whether recalling information, practicing a skill, or performing a brief cognitive challenge, the nervous system begins to recognize patterns. Neurons involved in these activities fire more readily, and their synaptic connections become stronger and more reliable. This is not a metaphorical change, it is physical. Dendrites grow, synaptic junctions thicken, and chemical signaling becomes more efficient. Over time, the pathways used in repeated mental effort become dominant, making recall faster, smoother, and more precise. Consistency is the method by which potential is transformed into tangible ability. Short, daily engagement is particularly effective because it aligns with the brain's natural rhythm of learning and recovery. Intense, sporadic effort often overwhelms the system, producing stress rather than growth. In contrast, a brief 10-minute practice every day respects the brain's capacity while maintaining continuity. Each session signals to the hippocampus and associated memory networks that the information, patterns, or exercises are worth revisiting. The brain learns to expect engagement, and anticipation itself enhances readiness. When the brain anticipates practice, it prepares metabolically and electrically, making the experience more productive even before it begins. Consistency also allows the mind to integrate learning with other biological processes. Sleep, for example, plays a critical role in memory consolidation, and daily practice ensures that new information is repeatedly reinforced during these restorative periods. Similarly, nutrition, movement, and emotional regulation interact with neural plasticity. When practice is consistent, these supporting systems can align in predictable ways, creating a holistic environment for memory improvement. Memory does not operate in isolation, it is deeply connected to the body's rhythms, and repetition harmonizes with these natural cycles. There is a psychological dimension to consistency as well. The brain is highly sensitive to expectation and confidence. Each successful moment of recall, no matter how small, reinforces the belief that memory is reliable and accessible. This confidence is not just emotional, it changes how the brain responds. When neurons anticipate success, signaling becomes more efficient, errors decrease, and retrieval improves. Consistent practice teaches the brain to trust itself, creating a feedback loop in which memory strengthens not only through direct effort but also through positive internal reinforcement. Even when progress seems subtle, the cumulative effect of daily practice is profound. Neural change is gradual, almost imperceptible in the short term, but over weeks and months, the difference becomes noticeable. Recall becomes easier, mental clarity improves, and connections between ideas deepen. This slow accumulation is the brain's natural way of consolidating growth. Unlike dramatic interventions or one-off efforts, consistent practice respects the tempo of the nervous system, allowing it to build capacity sustainably. Consistency also fosters flexibility in memory. When the same mental pathways are engaged repeatedly, they become versatile, able to support different types of recall and adaptation. Information learned in one context can be retrieved in another, because the underlying network has been strengthened through reliable repetition. This adaptability makes memory more than a static repository. It becomes an active, usable tool, capable of supporting problem-solving, creative thought, and daily decision-making. Importantly, consistency does not demand perfection or rigidity. The brain benefits from repeated engagement, not constant pressure. A missed day or a slight variation does not erase progress, it simply slows the reinforcement process. What matters is the overall rhythm of practice, the steady return to effort that signals value. Each engagement, no matter how small, contributes to the living network of memory, keeping circuits open and active. Consistency also encourages attentional discipline. By returning to the same type of exercise daily, the brain learns to focus and sustain effort over time. Attention and memory are deeply intertwined. Information that is noticed is more likely to be remembered. When practice becomes a habit, attention is primed, and encoding is enhanced. The brain begins to expect clarity, and in doing so, creates the conditions for stronger recall. The effects of consistency extend beyond memory alone. Habitual engagement with the mind strengthens overall cognitive function, improving problem-solving, reasoning, and creativity. The brain becomes more efficient, not because it is being forced, but because it has been trained to recognize, reinforce, and maintain valuable connections. In this sense, consistency is a form of nurturing. It supports the brain's natural processes, guiding them toward resilience and adaptability. Consistency also shapes the emotional context in which memory operates. Daily practice reduces anxiety about forgetting. The brain recognizes patterns of success and develops confidence. Stress responses diminish because engagement has become predictable, safe, and controllable. Memory thrives in this environment because the nervous system is not occupied with defending itself or compensating for uncertainty. The habit of daily practice transforms the relationship between the individual and the brain. Memory stops being a source of worry and becomes a cooperative system. Each day's effort is a message to the nervous system: this is important, this is worthy of attention, and this is to be maintained. The brain responds not with resistance, but with adaptation. Over time, the repeated, gentle signal of consistent practice leads to measurable improvements in clarity, recall, and mental endurance. In this way, consistency is less about time and more about rhythm. It is the repeated engagement that matters, not the intensity of any single session. The brain responds to patterns, and memory strengthens when those patterns are predictable, deliberate, and repeated. Over weeks and months, small, daily practices accumulate into significant cognitive change, creating a mental environment in which memory is not fleeting or fragile, but accessible, resilient, and naturally integrated into the flow of daily life.